Hello friends, welcome to my channel Civil Smart. Today we are going to design a BBS for simply supported doubly reinforced beam, and we have to draw a L section and a cross section of the beam also. In this Excel sheet you need to fill your data in these pink cells, and this will give you a length of the straight bar, stirrup calculation, number of the stirrups, length of the stirrups, then the tensile bar, compression bar, and the stirrup weight will be calculated, and finally the bending moment. Finally the bar bending schedule will be done. So we have a clear span of 4.5 meter. This is the wall bearing on which this doubly reinforced beam is supported. Clear span is 4.5 meter in this case, and beam dimension is 300. 300 is the width, and the beam depth is 450. And the bearing on the walls, and this is the support. The wall thickness is 300 mm, but the beam is supported at a distance of 200 mm. So bearing on the walls is 200, right? And the dia of the bottom reinforcement, that is a tension, because in the double reinforcement tension will occur at the bottom and the main tension reinforcement will be at the bottom. So dia of the reinforcement in tension is given, that is 20, and number of bars 2 in our case, and the compression dia of compression bar is 16 mm, top bar 16 mm, and the number of bars is also 2. The dia of the stirrup is 8 mm. This is two-legged stirrup, and the stirrup spacing is 200 mm, and the clear cover we are assuming for the beam is 20 mm on top and bottom and the side. So we have put our data, the input data of the beam. You can see that the L section, that is the L section, is being drawn by this Excel sheet, and this is the cross section at the mid span. 300 by 450 are the beam size. Now we can see for the effective length, that is L is the center to center distance. So clear span is 4.5 meter. We have put the clear span, and if the bearing of this beam is 200, then the center is at a distance of 100 mm and both sides. So effective span is L is 4.7 meter, that is 4700 mm. This value is in mm and this is in meter. Total length of the beam is clear span plus bearing. How much the bearing? 200 in this side and 200 in this side. So total bearing is 4.9 meter, that is 4900. Length of the straight bar, this is the straight bar. So what is the straight bar? Total length of the beam minus clear cover from this side and clear cover from this side also. So this is come out to be 4860 mm. Now we have calculated the length of the straight bar. Number of the stirrups in this case, center to center of the bearing, that is 4700. Center to center length, that is effective length, divide by the spacing of the stirrups, 200 mm. This is the 200 mm center to center, plus 1 is 24.5, and the round off value is 25. Now you can see that length of the one stirrup is 2a plus e. What is a? A is this length, vertical length, and e is this length, right? A plus e plus 2 into 10d. 10d is the hook length. Two hooks are there, so 2 into 10 times of d minus bend deduction. How many bend deduction? One 90 degree bend, 90 degree bend, and 93 90 degree bends are there, and 135 degree bends are 2 over there. So for the bend deduction, these are the values. So for by this formula, A has been calculated. A is overall depth. Overall depth is 450 minus 2 clear cover minus 2 dia of the stirrup. So you can see 394 is the A value. E is 244. B is 300 mm minus clear cover from both side minus the dia of the stirrup, that is 8 mm. So you can see the formula is there, and 244 is the E value. So length of one stirrup by this formula comes out to be 1.34 meter. Now the bar bending schedule is very easy. We have already done in the earlier videos. Tensile bar 20 mm is the dia. We have put our dia 20 mm. Number of bars is 2, and the length is 4.86. You can see the length of the straight bar is 4.86. Now the total length is twice into 4.86. Weight per meter, kg per meter, if this is 20, d square by 162. Now you can see 2.47 kg per meter, and the total weight is, because total length is 9.72 multiplied by 2.47 comes out to be 24 kg. Same for the compression bar, two number of bars, length is same, total length, and this is 16 mm dia, so the weight per meter is 1.58 kg per meter, so total weight is 15.36. And the stirrup, you can see 25 numbers of stirrups, and the length is of one single stirrup is 1.34, so finally the weight comes 52.59, and add 5% weightage, so 50.22 kg. Now if we are changing these dimensions, you can see if this is 6 meter if you are assuming, and the beam dimension is 350 by 500 if you are assuming, bearing on the walls is 250 mm, and the tension dia of the tension reinforcement is 25 mm, 3 numbers. Dia of the top reinforcement if you are assuming 20 mm, and the number of bars is 3 each. Stirrup dia is same. Now you can see the length of straight bar has been changed, number of the stirrups calculation has been changed, and the length of one stirrup has been changed. And you can see all the weight has been calculated. Now the 149.83 kg is the total weight of the reinforcement placed. So friends, if you like this video, if you want this Excel sheet, please mail me on my mail ID or WhatsApp me. So thanks for watching.